Good day to everyone. Architect Manalo, my panelist. Also, Architect Ate, also my panelist. And to my outside panelist, good day. Also to my advisor, Architect Adelia. I'm VICENTE Rusiana Jr., presenting to you my proposed project. This is Project PSS, Semantic Syntactic, applied to the proposed disaster-proof residential building. Geoffrey Broadbent, which is the theory of science, pragmatic, which is deals with the origin, kung asa nagdikan ang sa theory. The semantic deals with the signification of signs in all modes of signifying, with the ways in which they actually carry meaning, and the syntactic deals with the combination of the signs. And syntactic, which is putting together into form with regard to the specific signification of meanings and relation, behavior in which they occur. So this is the proposed building, which is really the wind path, the amihan and the habagat. So this is the features they have put into the building. The solar panels, which is here. Solar panels is also known as PV panels. It is for the conservation of electricity. The glass panel, the natural light coming in the building, and also with its external beauty. The concrete, which is the main structural component of this proposal, can make the building stable, firm, and strong. And as we all know, concrete is a type of construction way back, so it is not new. So it is elevated from the NGL. This one. It is the road. And, the building is elevated, and furthermore, we can see the actual elevation of it. So this is my design concept: a waffle, which is a food. So I like food. We like food. So before building a disaster proof, you should be eating food. So that's why I my design concept is waffle. Also the stone, the firmness, the resilience of the stone. It could be my um, concept because disaster-proof residential building should be firm. The resilient, the firmness of it is coming from my concept, which is the stone. Then also the transistors, the chip that it can absorb all the energy, all the data given by the transistor, the resistors, the capacitor, the diode. So it is also applied in my building because the building itself can absorb all the loads, the pressure, the uh, the vibration, the earth because of earthquake, So these also the aggregates. It can make the concrete more stable, more firm. So the rebars that can carry, that can absorb all the stress, vibration in the ground. So this one here is the main part of the proposal. I call it cross rib concrete box. Why cross rib? It has a rib, this one. Why cross? Because it cross. So it is a box with an area of 3 by 3 meters, and also the height is 3 meters. It is a prefab box which has 4,500 psi concrete mixing. It is a solid box. So I choose this one, or I came up for this concept because uh, in every earthquake that we encounter, di ba, sa Bohol. So I put it in my book, in my manuscript. Sa Bohol kay they use light materials, even though they use a concrete, but it has a low psi. So that's why with the earth or with the ground shaking, it easily collapses. So for this one, I designed this one with um, uh, with a concrete. It has a 4,500 psi. I think it's class AA. So it is firm like a stone. It's a hole, so it can absorb all the loads, the shaking in the ground. So it is form. Wait, this one. So this is the waffle construction, and this is the cruise reef construction. So as you've seen, um, this one here, here, this one here, this is the part that kuan kanang contact is it is contact with ground. So when there's shaking, kini sila ang modawat sa shaking, especially sa magnitude. I mean sa kuan sa earthquake. So kini nga area, it has 1, 2, 3, 4, 5. It is a 5 boxes sa akong proposal kasi it's a 1-story single bedroom, like all of katulang yung pinakaubos nga mga klase sa proposal nga mga balay. So I used 5 boxes. So when the earthquake start with this one, with the load here, also the load here, you're shaking, all the loads, all the vibrations will carry, it will absorb with this one because kini man ang nagkuan sa ground, kini raman sila ang natapot sa ground. So imo siyang divide doon, load, divide, earthquake load ba na siya? Basta load, divide sa kung pila ni siya ka ribs. 1, 2, 3, 4, 5, 6. 6 ribs. 1, 2, 3, 4, 5, 6, 7. So, sa usa ka kuan, bali daghan na ang iya ma-divide. So, di na siya ingon nga mo shake. Di na siya mas kusog. Besides, ang kini nga mga ribs nag-connect, it is connected square. So, connect siya tanan. And also the reinforcing bars, it is connected also sa tanan gyud from the ground and also this one here sa paghimo niya. So it is connected. So kung naaman lay mga load nga kusog, at least dili siya ingon nga ang pag-uyog niya is grabe gid lamang ka kusog, and it is bolted kining lima, di-bolt siya og tarong. So para mas, as I have said, ay kanang nikuan jud ko ni focus ko sa stone, it is firmness and the strong type kuan niya kanang murag characteristic. So no, di na mo balik. So flood resistant building techniques. This techniques kini mga techniques mo ni akong gigamit. Lots of kanang techniques mga akong gigamit para ani nga proposal. So first is building relocation. So we should relocate properly the building nga manggod nga kung asa gid siya dapat ibutang. And I hope sa atong gobyerno ay pangusgan gyud na siya kay it is a safety manggod sa mga tao diri. Kung unsay may tabo sa mga tao, ari ra gyapon padulong nato sa gobyerno, kay padulong sa ato ang nasod. So bisan pag unsaon pag-design siya, but kung ang iyang location manggod, it is for me manggod sa this design is just a theory and a prototype, and it can mabuild ni siya bisan asa. So building relocation manggod, kabalo ta kung asa siya dapat mabutang. So next is the building elevation, elevate ang building, so makita nato ang mga kung unsa nato na siya pag solve mga inana. Next is this is my floor plan. Di na kaya na ko siya i-discuss because it's just a typical floor plan of a building. So typical na siyang building, typical na house, it's a 1-story house. So front elevation, left side elevation, rear elevation. This one here, dili na tamag sugod. This is my proposal kung earthquake proof siya. Di man lang sa ingon nga proof nga di gid siya mahugno, but it can kuan lang kanang minimize lang iyang damage because this manggod nga mga proposals basta nature na gani ang murag inta kontra lisod kayo pag anticipate ana earthquake wa ta kabaw kung kanus amo abot, wa ta kabaw kung unsa kay kusgon. Yeah, kabalot akong mga fault line kung asa dapit, but the fault line itself kay magusab-usab siya na nasa iba nga mga fault lines. Kung unsa kada ka sa fault line, wata ka ba kung unsa kada ka nga linog. So ang proposal lang nako is kanang kuan lang siya. It can, yeah, damage but minimize lang. Dili siya ingon nga mahugno gyud, same as nahitabo sa Bohol, same sa tanang mga nahitabo sa mga earthquake kuan niya. So I came up to kanang may nga nakakuan ko sa ako ang self nga unsay mga nindot ng mga features for earthquake nga makakuan tagamay, murag may nga nga murag maka-save tagamay. Di man lang nato gani masuhid ang Japan. Because Japan is just kuan jud kayo, grabe high tech na ang Japan. And so naning kamot ko nangita ko paaging kung asa ko pwede, kung unsay pwede na kong gamiton para ani niya. Ano man? Ang akong the concept itself is kung mag-shake ang building, makaya na sa katong box, the grocery box, makaya na niya kasi ang shaking. Minimum lang siya, mabangin naman siya. But ang ko lang is, what if there is an earthquake na kusog jud? There is crack man gyud, especially it is a bisan ang bato imo nabukon mo crack man gyud siya. Not totally nga mo kuan siya, but naagi siya part nga mo crack. But kung imo na siyang applyan og features, applyan og something nga kanang murag ingon ta nga makalas pagyud ta sa iyahang kanang murag pinaka dead end na gyud sa concrete para mo crack, and pinaka elastic na gyud sa iyang steel ka para maputol, mangita ta and ato na siyang i-apply. So nakuha na ko ni siya nga concept, this one here, kini siya as nakita